done. We talked about continuity a little bit, but we think we're going to get a little bit more into it. So let's just start talking about the types of discontinuities. Continuity is like if everything's smooth. Let's define that. Function is continuous at the point. Let's call that point C. You can call it whatever you want. Don't get confused by the C. It's just a random point. I'm just calling it C. If the limit as x approaches C equals f of C. Is there a blank page nearby in your book? Go to the blank page before 1.11. I need to, in the middle of the woods, I'm developing territory somewhere, and I need to make a road that goes over a river, and then connects to the road on the other side. So first I call Carter's company. Carter, I need you to come build this road for me. So he builds a road. He forgets to build the bridge. He builds the road on the other side. And I'm like, dude, you didn't build a bridge. So he comes back and puts the bridge up there. I still can't get across the river, and we're screwed. So then I'm like, all right, you're fired. I'm going to call Will. Will comes by. Yeah, you suck. Will comes by, and he's like, tell me you didn't even build a bridge, so I'm going to do that. Then he goes home, kind of comes back the next day, starts building the road, and he builds it to the wrong spot. So it doesn't match. Then I call Jen. She's like, I didn't even make the roads match. Let me do it. And she leaves. And that's it. And I get to the road, and I'm like, I can see the other side, but I can't get there.
So you just like destroying the roads.
Yeah. And theoretically, hypothetically, they all just wipe out. Start over. One more. Oh yeah, okay. So then I call Strip. Strip, I don't know. Strip is on some serious drugs or something. She's like, road, bridge. What am I supposed to do with that? You don't have to write it yet, but we're gonna use this for a bad thing in a second. It's fun, but there's also purpose to it. Yeah, so then I call Bustle, and Bustle starts building the road, and he just kind of forgets where he's going, and he just wanders off in this direction. And then he does the same thing the next day, but from the other side. You just start that's perfect for Noah, right? You just wander off.
So Jenny does not that. Did Jenny just not build a bridge?
Jenny just didn't build a bridge.
Okay.
I don't know what. I'm supposed to just stare at the other side.
Okay.
What good is that?
Manifest yourself over there.
Yeah.
So far, I've actually done
The power of
So
fire.
far, yours isn't bad.
What
Yeah.
do you jump off?
What else?
And mine has a little ramp.
With the power of God, you learn to walk on water.
Yes.
The power of horsepower.
Just learn
You
to
just
walk
jump
on
over
water.
the hole.
You're wasting so
Okay.
much
I think that's all the mistakes I can think of. So that I'm just gonna do it myself. You guys suck at this. And that's continuous. So this is continuous because the limit, I'm gonna call that point C. The limit as x approaches C is equal to f of C. What that's saying is the roads meet, there is a bridge, and those two things happen in the same spot. So this is continuous. Yeah, so then what I'm gonna do, so you know what to write, I'm gonna go through each one and say okay, mathematically, why is this not continuous? Not the bridge is in the wrong spot, but what's true mathematically that makes it not work. So I'm gonna write one little thing below each one. So if you want to write over. Were you guys writing or not?
I'm gonna do it.
I did. I think I meant to say okay, start writing now.
No, I'll do it when you.
That's fine. I'll give you a second if you want to write them. for a function to be continuous at that point, am I going too fast or am I going? Okay. These things have to be true. The limit has to exist, which means the roads meet, like it's the same for both sides. F of C has to exist, which means there needs to be a bridge, and they got to be in the same spot. So does the limit exist here? It does, and would it be the open circle or the closed circle? It'd be the open circle, right? The limit's like where the roads are headed.
I said close because I messed up.
That's okay. Is there a bridge? Is there an F of C? Yeah, but what's the problem with those two things? They're not in the same spot. So this is not continuous because, like, it's actually that top definition. The limit as x approaches C is not equal to F of C. So that's not continuous at that point. That is actually called a removable discontinuity. So you have the power to build bridges or move bridges. You cannot move or build a road. So I could remove this discontinuity. So I'm allowed to build bridges or move bridges. So if I could just move that bridge to here, would everything be okay? It's fine. And I got like a big crane, I can just pick up the bridge and move it. So this is discontinuity because they're not equal, but it's a removable discontinuity because I could fix it. I could get rid of that discontinuity if I could move the bridge. I forgot whose that was. So Will, what's wrong with Will's? We get a little more mathematically. Good. The limit as x approaches C. Put the C in the right position there. Yeah, thanks. So the problem here, Wells, I'm pointing out your mistakes, is that the limit as x approaches C of f of x, it doesn't exist. Which is the same thing as saying the roads meet, or like the bugs won't meet. Like if you use the bug thing, and that's, remember, I can move bridges or build bridges. If I move or build a bridge, does that fix that problem? It does not. So this is called a non-removable. What's up?
You just wrote F of X.
No, it's F of C. Or it's F of X. So that's the name of the function as x gets approached. As x approaches C. C is a number. So this would be like the limit of f of x as x approaches 2 is not equal to f of 2.
Oh,
You're gonna call me out.
But I was
No,
asking.
it's okay. It's okay. It's okay. I'm just kidding. Like I make mistakes all the time.
It's
And like, it's what?
Ella's fault.
It's,
She told me.
please point out mistakes. I make them all the time. And most of you guys here are smarter than I am. I just know the calculus and you don't. Like, point it out if I make mistakes. Yeah.
It doesn't say knowing what's right.
I agree with you, but like, it's a weird thing to do. Okay. Alright. This was Jenny's. What's wrong with Jenny's?
There's no bridge.
I don't know what that means. Mathematically. F of C doesn't exist. I can remove discontinuities by building or moving a bridge. Can I remove that discontinuity?
Yes.
I can fix it if I just build a bridge there, right? So that's removable. So Strip's got a few issues. What the fact that these don't connect, what does that tell us? Like mathematically, what's that? The limit does not exist. So the limit as x approaches C of f of x doesn't exist. And even if it did, f of C, like, the bridge is in like a weird spot anyways. So I remember I those two things, can I fix this? I can't. So that is a non-removable. I cannot remove it. Excuse me. I can build bridges and I can move bridges. And if moving or building a bridge closes the gap, then I remove the discontinuity. I got rid of it. So like if I could just move that dot, now everything's nice and smooth. I get over the river. So that's removable because I can fix it by moving the bridge. I'm allowed to build bridges and move bridges. But I can't touch roads. So like I can't fix this. Building or moving a bridge here is not going to make the roads happen. Is that all?
Yeah.
Okay. Buses. What's the problem with buses? There's a lot. Give me one, Noah. Yeah, I was trying to make it like a vertical asymptote. No, what's one of the problems? The limit as x approaches c of f of x. I'm just gonna say d and e. Yeah, it should be like d. Doesn't exist.
Well, it's D and E because it does not exist.
Yeah, I know.
It
but
doesn't.
D-
It's
D
never
would
doesn't
be
exist.
does exist.
We established that
True.
it never doesn't exist.
Okay. He's got another issue. He's got lots of issues. But what else is there? F of C doesn't exist either. F of C does not exist. That's supposed to be a vertical asymptote, but he didn't build a bridge. I'm allowed to build or move bridges. If I build or move a there's not one. So if I build a bridge there, does that fix the problem? It doesn't, because those roads are still not going to connect. Like wherever I build the bridge, then I still can't get over the river. So this is a non-removable also. And then the last one, everything's fine and it's smooth. But I want you to realize, like, it doesn't have to be like I write a dot there. Like this function is continuous here, 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 here. Like all along there, there's actually dots, right? So there doesn't have to be a dot for you to say that the roads need the limit exists. Like even this one, like, is this function continuous right there? Yeah. Because the roads come together, there's a point there, and everything's fine. Questions on this one? Yeah. Especially for you, because you guys work through on your building.
Yeah, we still do some.
Yeah, maybe I just paid like 6 people.
But since you built the correct bridge, I think you take a picture of that and you send it to a contractor and be like, hire me with what I did.
Yeah, no, good job.
Yeah. Because you're experienced now.
Good. Oh, wait. No, this is my fault. You're fine. But I told them about the test. Like, just take a positive, negative, zero. Because estimating is like something. But you're positive. Yeah,
I think that's right there.
Nobody here can build a bridge.
nobody.
Only Mr.
You're only useless. Okay. So,
No, Curtis was the one.
Carter's
who built
road
the
met, but the bridge was like,
Oh, Curtis was the first. Yeah.
yeah.
I think
You need to careful
really
bridge
like it.
over acid.
I really like Noah.
You didn't ask to do that. You asked Sophie.
Oh, he's going.
I don't know if you guys have noticed, but I'm moving on. Yeah, thanks. So there's 3 types. I'm gonna put like a little note about each one. So removable discontinuity. Algebraically, because you're gonna have to do these without graphs too. Like I'll just give you an equation and say where the discontinuity is at what time. Algebraically, if you get 0 over 0, that's a removable discontinuity. If you remember, that's the kind where like if you get 0, 0 on a limit, what does that tell us? Keep going, try something else, because the limit does exist. And in a removable discontinuity, when there's no bridge, does the limit exist? Because the roads do come together. So this means the limit still exists, but you gotta do something else to find it. Another way to think about that is the factors cancel, so I'll show you both of these in a minute. And on a graph, it just looks like a hole. So then there is a vertical asymptote. These 2 types are two types of non-removable. Vertical asymptote, which I never know how to write this, but it's like something on top that's not 0 over 0, 4 over 0, 10 over 0, negative 30 over 0, whatever. It's a vertical asymptote. Or I'll show you both ways to think about it. The factors don't cancel. And then, on a graph, it's just like that vertical dash line. The third kind is called a jump. Because you're here and you have to jump to the next one, there's that gap there. And that comes when I can't spell this, I can see it in my head. Pieces of piecewise. Give different limits, which is like saying the roads don't meet. So a jump can only happen if you have a piecewise function. But just because you have a piecewise function doesn't mean it's going to happen. So that's kind of that's the stuff that I'll put on your cheat sheet. That's the notes, that's the big topic overview, and then let's start going through some problems. So if you notice algebraically, number one is not a piecewise, right? So we don't have to worry about a jump discontinuity. We have to figure out if it's a vertical asymptote or a removable discontinuity. What do those two things have in common? Vertical asymptote and removable discontinuity. And a zero bottom. So my first step is set the bottom equal to 0. So I'm gonna do this twice. Because there's kind of two ways to do it. I'm gonna do it twice. So I'm gonna do it like the way where I set the bottom equal to 0 first. So then I gotta solve that. It's a quadratic, so I'm gonna factor and cancel. So multiply to negative 10, add up to 3. So it'll be positive 5, negative 2. But then my actual solution x equals 5, and x equals 2. That work good? So those are discontinuities. But I don't know what type yet. Because if the bottom equals 0, you do have a discontinuity. But then I have to label. So you're going to plug these back into the top. This is method 1. So if I plug negative 5 back into the top, all I would care about is do I get 0 or not? I don't even care what the number is. Just is it 0? So 25 minus 40 is negative 15. Sorry, that'd be plus 40. 25 plus 40. Am I going to get 0 on top? I am not. That means, so this comes out to something else over 0. So this is a vertical asymptote. You have a vertical asymptote at x equals negative 5. That's what I'm going to do next. So then x equals 2, I got to plug it in also. Well, that'd be 4 minus 16, which is negative 12, plus 12. So now I get 0. So when I plug this one in, I did get 0 over 0. So that is a removable discontinuity at x equals 2. So what I boxed in is how you would answer it. I want to know where they are and what times. Questions on that technique? Yeah. No. I mean, if you want to get it wrong.
What's the difference?
It's not technical. It's not like math words. Yeah. The AP just wants to see the vocabulary. Alright, let me do this another way, which is very similar, just a little bit different way of thinking about it. So instead of setting them both equal to 0, I'm going to try to factor it. And I'm going to say, okay, f of x equals, top is x minus 6, x minus 2. Bottom is x plus 5, x minus 2. So, if you go back and look at what I wrote up there, the removable discontinuities happen when the factors cancel. You got to be careful because it's the solution of the factors that cancel. So, like these two factors would cancel. That's a removable discontinuity, but it's at 2, not at negative 2. That's like what the solution would be if I set that equal to 0. So, because these cancel, I can say there's a removable discontinuity at x equals 2. And the reason it's the same thing, like if I plugged in 2, that would give me a 0, that would give me a 0, so I would end up with 0 over 0. This would not cancel. So if it doesn't cancel, oops, they don't cancel, just leave it there. That is a vertical asymptote. At x equals, at the solution to that, not at 5, but like what you get if you set it equal to 0. So that way shorter, but my fear is you'll like get confused, put like 5 instead of negative 5 or forget which is which. But that's, you do whatever you want. Some people think one's easier, some people think the others. They're both very valid. Questions on one? Either of those? So I would like you to try both methods on number 2. And eventually you're going to pick the one you like, right? But try both on that one. Factoring might be a challenge there, I don't know.
So there's another discontinuity. Now, if I solve this one, divide both sides by 2 or multiply by 1/2, I get 5 pi over 4. So while it's true, the setup I had with 5 pi over 2, while that is outside this range, when you actually solve for x, that's not. The x value is still within our given range, and so we can keep going. So you have to keep checking. So let's go to another one. 2x equals, what's the 7 pi over 2? 7 pi over 2. If I divide both sides by 2, I get 7 pi over 4. And that's still within this.
Two has like the stuff we're learning, but I'm not sure we like get 100% of this factor. 5x to the 4th minus 1. I would set that up as x squared plus 1, x squared minus 1. That's the difference of squares, right? The square root of the first thing, the square root of the second thing, and put a plus or minus. But am I done? I'm not done, because isn't that also the difference of squares? So when you factor this, you got to factor whether you're solving or whatever method you're using. That is the factored version of that. If you didn't get that, you're kind of stuck. So I just want to show you that part. I'll read back to this. is, one would be set the bottom equal to 0, and let's work from there. Well, if I set that equal to 0, there's no solution to that. When you square a number, it turns positive. If you add 1 to a positive number, you can't end up with 0. Or, think about it like if I subtracted 1 from both sides and then square root it, now I'm taking the square root of negative, and I can't do that either. So that doesn't even give me any solution. That's like meaningless. This would give me x equals negative 1. This would give me x equals 1. If I plug negative 1 into the top, I'll get 0. So if I get 0, what's that tell me? Removable discontinuity. Rem disk. And if I plug 1 back into the top, I won't get 0. So what's that tell me? Classic. Or, if you're doing like the canceling way, so those two would cancel, which means the solution from that, which is x equals negative 1, is removable. This one doesn't cancel with anything, so the solution from that is a vertical asymptote. And this one has no solution, so we just forget it exists. How's that? How many would do? I'm just curious. Like if I gave you one more right now and said do this, how many would do? Like you set the bottom equal to 0 and then plug back in. And how many would do the factor and cancel? What do you mean you didn't do either? You did one of those in your head. You can't just factor in. So you're doing the factor and cancel. Just like not formally. The trig ones we're gonna skip for today because I'll take the last two for it. Number 4. There are no issues. How do I know that? Issues come up. Well, yeah. So the issues come up when there's a piecewise that doesn't match. That's not a piecewise. Or the bottom equals 0. That is no bottom. That was totally continuous. You would say this is. You would say it's everywhere continuous. So there's only discontinuities if the piecewise. If it's piecewise, they don't match. But that's not piecewise, so that's not an issue. Or the other issues come up when the bottom equals 0. But that bottom can't be 0. So it's just there's no issue. So I would like you to do the ones in the assignment that are trig. I think there's only like 2 trig ones, 3 trig ones maybe. And we'll do those just tomorrow. Are there any piecewise in that? No? I mean, that's like the next section. Like, there's half the piecewise in this section. The next one.
It looks like you want to Does it exist?
Oh, yeah. Hopefully it's in the right spot. Jessica the only person absent? Good job. This one is kind of describe. You did this kind of this one. Like which could be represented that one that doesn't exist. Did you like so this one like you're adding two, right? It's linear, so you're adding two to 12 up to the 7. I think you just like you're confused with not double negative yourself. Yeah. The right hole. Don't hit the play. So I think an answer key writes whole, a couple of them, but that is not a mathematical term. If we'll say whole in the AP test, they don't want you to say whole in the AP test. Is that, I'm sorry, like that rem disk? Yeah, you can do that. You do rem disk. That's better, right? Rem disk. REM for removal and DISC for discontinuity. Let's say like one type of discontinuity, then you can say yeah, that's easier than rem disk. Whatever. Oh, I'm looking at the graph above. Okay. The U's mean like also.
Okay, yeah.
Good. Soft, like the parentheses don't include the number, and then bracket, the hard bracket does. So as far as we get into, we'll finish up with like the tree ones, and then we get into piecewise. We kind of already talked about it, but we can do more, we can do better. You all in?
I'm all in. I barely know what it is.
That's
I'm in the group that like.
no, I'm thinking on that. Yeah.
Yeah, I think like there, I heard about Pep Rally and that's about it.
They talked about it.
No, I said there's gonna be some sort of Pep Rally for the school, and that's about it.
Oh, I didn't know what that. Talking about like school spirit, school pride, school
Yeah,
culture.
and how to like improve school culture.
It's like one thing I noticed, like I go to other schools, like airport for example, it's blue and gold everywhere. Airport, jets, no jets. And like when you walk in here, it's just like a white prison, you know? Like look at this wall. Yeah, so that's one of the things I'm trying to say. You all in too? You like share the document?
I
it's like hard to, I feel like I'm huddling over your personal space.
Yeah. So catch it. Yeah, if you want to go absent as many of those, then
I'll just wait for it. If you can't share it.
Do you want just the spreadsheet, or do you want like a website that has it all?